Hello everyone, I am Sindhu GS. I am practicing at JSS College of Arts, Commerce and Science, Uti Road, Mysuru. Today I am going to explain about gravimetric analysis. Gravimetric analysis. Before going to our topic, let's know about what is analysis. Analysis is a process that provides physical or chemical information about constituent in a sample or sample itself. There are two types of analysis like qualitative analysis and quantitative analysis. Qualitative analysis that determines the identity of the constituent species present in the sample, whereas quantitative analysis determines the how much of constituent species present in the sample. For example, gravimetric analysis, volumetric analysis and instrumental. So, this gravimetric analysis comes under the quantitative analysis. So, let's move on to our topic, gravimetric analysis. Gravimetric analysis is a quantitative analytical technique where the mass of a substance is used to determine the amount of analyte. Gravimetry is a method used to measure the weight or amount of a substance by converting it into a solid form precipitate through a chemical reaction. The process determines the amount of substance in its pure form as a solid precipitate. Now let's break down the terms. Gravi means mass and metry means measurement. Together, gravimetry means the measuring the mass of the precipitate to determine the amount of substance. Now, let's see the principle of gravimetry. Gravimetric analysis is based on converting ions or elements into a pure solid forms through a precipitation reaction. These solid or precipitate can then be easily weighed and measured to determine the amount of the substance. This picture demonstrates the steps involved in the gravimetric analysis. Now let's move on to the steps involved in the gravimetric analysis. There are some few steps that involves in the gravimetric analysis like sampling, precipitation, digestion, filtration, washing, drying or ignition, weighing and calculation. Now let's see the first step, sampling. First, prepare a solution by dissolving a substance in a suitable solvent. Withdraw a sample from the bulk material, for example barium chloride. Barium chloride reacts with sulfuric acid and gives barium sulfate as a precipitate and hydrochloric acid. This results in the formation of barium sulfate precipitate. The second step is precipitation. To prepare a precipitate, add a precipitating reagent to the solution. Precipitation is a process of forming a solid from a solution when a chemical reaction occurs. Precipitation is necessary to convert substance into their pure forms. For example, dilute sulfuric acid can be used as a precipitating reagent. The third step is digestion. Digestion is a process where smaller particles of a precipitate are converted into larger particles by allowing the precipitate to stand in the presence of mother solution. Mother solution is the solution that contains the precipitate. The precipitate is allowed to stand for 12 to 24 hours at the room temperature. To increase the rate of digestion, the temperatures can be raised. The fourth step is filtration. Filtration is the process of separating the precipitate from the mother solution using filter paper, Waldman filter paper. The filter paper retains the solid which is called the residue. The liquid that passes through the filter paper is collected below and this is called the filtrate. The fifth step is washing. During the washing process, precipitate may be contaminated with impurities. It is necessary to wash the precipitate to remove these impurities. Wash the precipitate using warm water or a suitable solvent. The sixth step is drying. Drying or ignition is used to remove the water from the precipitate that remains after washing. Drying can be done by heating the precipitate at 110 degree to 120 degree Celsius for 1 to 2 hours. This can be performed at much higher temperatures if the precipitate needs to be converted into a more suitable form for weighing. The seventh step is weighing. After drying, allow the residue or precipitate to reach the room temperature. Weigh the residue accurately using an analytical balance. Let's see the calculation part. Calculation of percentage purity of a substance can be done by using a formula, that is Ws divided by W into 100, where Ws is the weight of the substance and W is the weight of the sample. This may also be included in some cases depending on the specific analysis. Let's see the applications of gravimetry. Gravimetry is used in the analysis of standard solutions to determine concentrations accurately. While gravimetric method can be time consuming, they provide better accuracy and reliable results compared to some other methods. It is used to determine various ions like chloride as silver chloride and lead as lead chromate. In conclusion, gravimetric analysis is a fundamental and highly accurate technique in analytical chemistry. It relies on the mass measurement of a stable, pure precipitate to determine the quantity of an analyte. Though it is time consuming, it offers excellent precision and reliability. Understanding the systematic steps from sampling to calculation is essential for effective applications. Gravimetric method remains a gold standard for validating results in both educational and research laboratories. Thank you.